So what exactly changes when a company moves from one AI chatbot to dozens of AI tools? At first, it feels simple. One team adds a chatbot for customer support, another uses AI to search company documents, and meeting notes get written automatically. A workflow can read an email, pull out a request, and send it to the right system. Before long, the company has several models, agents that can take actions, and tools that reach into business data. Each team often connects straight to a different AI provider, using its own key, its own limits, and its own safety rules. Costs become hard to trace. A key can end up in the wrong place. And when an agent calls a tool, nobody may have one clear record of what it tried to do. This is where Microsoft AI Gateway comes in. By the end of this episode, you'll understand what it is, how its building blocks fit together, and when it starts making sense for your business. Think of it like an office building with lots of side doors. You could leave every door open and hope people use them properly. Or you can bring everyone through one managed entrance. One front door for AI. Microsoft AI Gateway is a set of Azure API Management features that gives your AI traffic one control point. Let's break it down in plain English. Imagine your company's AI setup as a modern office building. The AI models are rooms where the thinking happens. Your agents are workers moving through the building, deciding which approved task to do next. Tools are service doors that lead to places like HR, finance, customer records, and internal files. The AI Gateway is the reception desk and the security desk at the front. It checks who is coming in, applies the rules, and records where requests go before they reach the rest of the building. A request follows a simple path. An app, a copilot, or an agent sends a request to the gateway. The gateway checks the rules that apply to that caller, then sends it to the approved model, tool, agent, or business API. And when a response comes back, it passes through the gateway again before it reaches the user. That one path gives the business a place to manage access, limits, safety checks, and logging without building those controls into every single app. This also separates two jobs that often get mixed together. Application teams can focus on the experience people actually use. They build the support assistant, the document search screen, or the workflow that saves time. Meanwhile, the platform team manages the shared rules behind the scenes, deciding which services are approved, which identities can use them, how much traffic a project can send, and what gets logged. You don't want every team inventing a new security plan for every chatbot. Microsoft AI Gateway can sit in front of several kinds of AI traffic. It can manage calls to AI models and Model Context Protocol (MCP) tool calls. It can also manage agent-to-agent (A2A) traffic and the business APIs your company already uses, such as an API for checking an order, reading an HR policy, or opening a support ticket. That last part matters because most companies don't need to throw away their existing systems to use AI. They just need a safe way for AI to work with those systems, and a gateway helps put controls around that connection. Now, Microsoft AI Gateway isn't a model. It doesn't write answers itself. It isn't an agent builder either, so you don't use it to design an HR assistant or teach a finance agent what to do. And it doesn't replace Microsoft Foundry, where teams can build, test, and manage AI projects. Instead, it sits in the middle. Foundry can help you work with AI models and agents, while Azure API Management AI Gateway helps control the traffic those models, agents, and tools create. You may already know Azure API Management as a way to manage normal APIs. An API is simply a way for one piece of software to ask another piece of software for something. AI Gateway extends that same idea for AI work, because AI requests bring new questions. Who used which model? How many tokens did it consume? Can this agent call that tool? Should this prompt reach the model at all? Putting the gateway in the middle gives you one place to answer those questions, and the first pressure point appears when every application starts choosing its own model endpoint. One endpoint, many models. When your application connects directly to a single model endpoint, that choice gets baked into the code itself. Often the code is tied to one provider, one specific deployment, one Azure region, and a fixed set of limits. That works fine while the project is small, but imagine your support assistant runs on one model in one region. Months later, that model hits its capacity, a better model comes along for less money, or your business needs to move to another region. Without a shared layer, every app team has to change their code, test it again, and roll out an update. That makes for slow, messy change. Microsoft AI Gateway gives your applications a stable front door. They send requests there, and the model choice can change behind the scenes without you having to touch the app. Think of it like a company phone number. Customers dial one number even if the call gets passed to a different team or office. They never need to know how it's handled. With AI Gateway, your app calls one approved endpoint, and behind that endpoint, the gateway sends the request to the model that fits the job. Microsoft also has a newer approach called the Unified Model API. In plain English, it lets an application use an OpenAI-style way of making a request, while the gateway can connect that request to different model providers behind the scenes. So your app sends one familiar kind of request, and the gateway handles all the provider details. Depending on your setup, that request could go to an Azure OpenAI deployment, a model in Microsoft Foundry, Anthropic, Google Gemini, or Amazon Bedrock. The route follows rules you set, not a hard-coded choice buried inside every application. That gives the platform team room to make changes without disturbing the people who use the app. Say your company runs an AI assistant for customer support. Most questions are simple. Where is my order? How do I reset my password? Those can be answered by a smaller, cheaper model quickly without spending more than needed. Then a customer sends a long, unusual question that needs careful reasoning or product knowledge. The gateway routes that type of request to a stronger model. The support app still sends requests the same way, so your team never needs to know which model handled the question, and your developers don't have to wire up separate connections for every option. What about capacity? AI model endpoints have limits. They can only handle a certain amount of traffic during a period of time. If every request hits one deployment, a single busy hour can slow down or block the whole experience. A gateway can spread traffic across multiple approved deployments, routing to another region when one fills up, or using a backup route if an endpoint goes down. That doesn't mean requests should bounce around randomly. You still set the rules. For example, customer-facing traffic gets priority on your main model while internal testing uses a different path, or one region handles local users while another acts as a backup. The point is simple. Your applications connect to one controlled front door, and behind it the platform can adjust models, regions, or providers with minimal disruption. That matters because AI moves fast. A model that works today might not be the best choice next month. If every app talks directly to its provider, changing models becomes a project for every team. With the gateway, the model decision lives in one shared place. A quick note on the Unified Model API. Microsoft lists it as public preview. Preview features can change, and they may not be ready for every production use case. Still, the larger pattern doesn't depend on that one feature. Azure API Management can already sit in front of model endpoints, apply routing rules, and help you manage more than one backend. The Unified Model API aims to make that cross-provider experience easier for applications. Choosing the right model is only half the job because a model can answer a question, but an agent can decide to take an action that reaches into real company systems. Governing agents and tools. An agent takes AI beyond just answering questions. It's software that can look at a task, choose from approved options, and call a tool or service to get work done. An HR agent might look up a leave policy, a support agent might check an order, and a finance agent might prepare a payment request. That ability is useful, but it also changes the risk profile. A wrong answer from a model confuses someone, but an agent using the wrong tool can expose data, change a record, or trigger a process it should never touch. This is why tools need rules of their own. You'll hear the term MCP, or Model Context Protocol. Think of it as a standard connector shape that gives an agent a known way to find and use a company tool like a document search service or order lookup API. Rather than building a different connection for every agent and every system, MCP gives teams a common pattern. Then there's A2A, agent to agent, a standard way for one agent to contact another. For example, a support agent asks a shipping agent for delivery details instead of trying to understand the shipping system itself. That sounds tidy on paper, but an agent chain gets complicated when every connection has different access rules, hidden credentials, and unknown tools. Imagine a finance agent that answers invoice questions. It should only use an approved invoice lookup tool, but someone gives it broad access to the finance system because it's faster than defining a narrow tool. A user sends a harmless-looking prompt, but hidden instructions in an attached document push the agent toward an unapproved action. If the agent has too much access, it might request unnecessary data or start a workflow that should need human approval. The agent isn't malicious. It just had too much freedom when handling untrusted input. Microsoft AI Gateway lets you put controls in front of MCP servers and business APIs. Instead of a direct path from an AI app to a database, you expose a small, controlled tool for one specific job. For example, an agent asks, check the status of this order. The tool returns just the status, not every order or the full customer record. It's a narrow job, and the gateway checks who's asking before allowing the call. Identity sits at the center of this setup. With Microsoft Entra ID, apps sign in through managed identities instead of sharing provider keys. A managed identity proves who it is without a developer copying a secret into code. Each agent should have its own identity. That way you can see which agent called a tool, revoke access for one agent without breaking others, and apply different rules. An HR agent shouldn't inherit a finance agent's permissions just because both use AI. This follows zero trust. Check every request, give only the access needed for the current job, and assume any prompt or tool response could be unsafe. In practice, the agent gets permission for one specific tool and action. It can read a leave balance but not download the payroll file. It can create a draft support ticket but not close a case. The gateway also applies safety checks to prompts and tool traffic. If a request contains harmful content or data that shouldn't leave the system, a policy stops it before reaching the backend. No filter catches everything, but checking traffic at a shared point is much safer than hoping each agent builder adds the same protection. You also need a catalog of approved tools. API Center acts as a private catalog for APIs and MCP servers, so teams find the right tool without searching old docs or copying unverified web addresses. That helps turn "which tool can my agent use" into a controlled business decision. Security controls protect the path, but they also create a new question: which teams are using that path, and how much AI usage are they creating? Token costs, limits, and visibility. AI costs work differently than a normal software license. The meter runs on tokens. What's a token? It's a small piece of text. A short word might use one token. A longer word uses more. The model counts everything you send in: your question, the instructions you add, any documents you attach, and the answer it gives back. So a simple question uses very little. But an agent that reads a long policy document, asks follow-up questions, calls a tool, and then creates a detailed answer can use far more than you expect. You've probably seen this with a meeting transcript. You see a few pages of notes. The AI system also processes its system instructions, the transcript, retrieved company data, tool results, and the final response. Every part adds to the usage. That's why one busy agent can eat up a shared model limit surprisingly fast. Imagine a team testing a new marketing assistant on a Friday afternoon. Someone gives it a large set of campaign files and asks it to compare, rewrite, and summarize them in a loop. Meanwhile, customer support depends on the same model capacity for people trying to get help. If the test workload uses the shared quota, the support assistant may slow down or fail when customers need it. The problem isn't just that the company spent money. The wrong workload took capacity from the workload that mattered most. Azure API Management AI Gateway can apply limits before that happens. You can set request limits, token limits, and quotas for an app, team, project, or consumer. A quota can cover a short window, tokens per minute, or a longer period like a daily or monthly allowance. That gives each workload a boundary. The marketing assistant can have a budget that fits its purpose. Customer support can have its own allowance and a higher priority. When the marketing assistant reaches its limit, the gateway can reject or slow its next requests. Customer support keeps running because one test project can't use everything available. This also changes the monthly cost conversation. Without a shared view, a finance team may receive one large AI bill and ask, "Who used all of this?" The answer can be hard to find when teams connect directly to different services with shared keys. A gateway can record the caller, the model, token use, response status, and the tool calls linked to a request. That gives you a clearer trail. You can see whether the spending came from an HR assistant, a developer test environment, a customer-facing chatbot, or an agent that kept retrying after an error. You can also spot unusual patterns, like one application sending much larger prompts than normal. If your teams start in Microsoft Foundry, the gateway can connect to that work too. Foundry projects can use project-level token limits while the gateway applies the traffic rules around them. That gives AI builders a simpler starting point, while the platform team still has a shared place to manage limits and monitoring. There's also a useful feature called semantic caching. Say one employee asks, "Where can I find the travel policy?" A few seconds later, another asks, "Where is our policy for business trips?" The words differ, but the meaning may be close enough that the gateway can reuse a suitable earlier answer rather than calling the model again. That can reduce cost and speed up the response. It only fits questions where reuse makes sense. You wouldn't cache a request for someone's current leave balance or an order status because those answers can change. Routing can help with cost as well. A company may send suitable work to a lower cost model, use capacity it already reserved before paying for extra usage, and switch to a backup path when a limit appears. Still, a gateway doesn't remove the need for ownership. Teams need budgets. Someone needs to review model answers. Someone needs to decide whether an agent should exist at all. The gateway gives you the meter, the guardrails, and the record of traffic. It doesn't make business decisions for you. Once you can see and control the traffic, the whole setup becomes easier to picture in one everyday example. A simple request journey. Picture an HR assistant inside a company. An employee asks, "How many days of parental leave can I take, and can you start the request for me?" The aim is simple: give the employee a fast, useful answer, then help with the next approved step. But the HR assistant must not hand out payroll data, open every HR file, or carry a model provider key inside its code. The request starts when the employee signs in. Before the assistant sends anything to a model or a tool, the gateway checks who the employee is, whether they can use the HR assistant, and which limits apply to that app. The employee sees one simple chat window, while these checks happen behind the scenes. Next, the assistant needs an answer. A basic policy question can go to the company's approved model endpoint. If that endpoint is busy or reaches a set limit, the gateway can follow a backup route that the company already approved. The employee still gets an answer through the same HR assistant, rather than seeing an error because one model deployment became too busy. Then the employee asks to start the leave request. At this point, the agent needs more than a model. It needs a tool that can check the employee's details and create the right request. The agent asks to use an approved MCP tool for leave management. The gateway checks that request too. Can this HR agent call this tool? Is this employee allowed to start this type of request? Does the action fit the permissions assigned to the agent? Only then does the tool receive the call. The tool does not return a giant list of employee records. It returns only what the job needs: the employee's available leave balance, the policy that applies to them, and a confirmation that the request was created as a draft. That narrow response matters. The agent has enough information to help, but it does not get broad access just because it asked a question in plain English. Now imagine the employee pastes text from an outside document into the chat. The text contains instructions that try to trick the assistant into ignoring its rules or requesting confidential information. The gateway can apply safety checks before the prompt reaches the model or before a tool receives a request. If the request breaks a rule, it can stop there. The same kind of check can review a response before it reaches the employee. Not every problem comes from a bad prompt either. A model might produce a response that includes information it should not return. A shared control point gives the company a place to inspect that path and act on it. Meanwhile, the request creates a record. The company can link the token used to the HR assistant project. It can see which model handled the question, whether the tool call succeeded, whether a request was blocked, and how long the process took. That makes support and review much easier. If an HR team reports that employees cannot create leave requests, the operations team can look for failed tool calls. If a safety rule blocks valid questions, they can see the pattern and improve the policy. If one agent suddenly uses much more AI capacity than normal, that change becomes visible. And if the company updates a rule, like requiring an extra check before certain leave requests, it can update the gateway policy once. It does not need to wait for separate code updates across every HR app, chatbot, and workflow that uses the same controlled path. The same request pattern still works when the company adds another model, a new region, more internal tools, or another agent that handles a related HR task. Start small though. A gateway becomes useful when AI traffic starts to become shared traffic. Where to start? So, where do you actually begin? Start by picking a single real workload, maybe a support assistant that already calls a model, or an agent your team plans for HR, finance, or internal document search. Don't try to tackle every model and every tool at once. That's a fast track to chaos. Instead of giving provider keys directly to every application, put that workload's model endpoint behind Azure API Management AI Gateway. Think of it like a single security checkpoint for your AI traffic. Then set the basics. Name a clear owner for the workload. Use Entra-based access so only the right people or services can reach it. Set a token limit that fits the job. No more, no less. Turn on logging so you can see what's happening. Add one content safety rule your team can test and review. Start simple. Once the model path and access boundary are working, add approved MCP tools one at a time. Each tool should have a narrow job and a clear reason for the agent to use it. No unnecessary extras. From there, you grow from one controlled workload to shared models, tools, and agents. Without that initial control point, every new AI app creates another unmanaged path into company data and another line on the AI bill. For the next knowledge nugget, look at Azure API Management simply explained. That's the foundation Microsoft AI Gateway builds on.